Welcome to our tutorial about Simulation Express. Simulation Express was known previously as Cosmos Express. Simulation Express is a limited version of SOLIDWORKS simulation, and that package was formerly known as Cosmos Works. Basically, Simulation Express is an easy-to-use wizard for a simple stress analysis on a single part with simple constraints. It does a simple stress analysis on a simple part of a single material. Simulation Express does have a few limitations. As I mentioned before, you can use Simulation Express on a single part only and of a single material. As well, the material has got to be linear, such as steel. In other words, let's say I apply a 1-pound force which deforms the material 1 millimeter. Under 2 pounds of force, a linear material should deform 2 millimeters. As you can imagine, nonlinear materials like rubber and plastic don't work this way. At the other end of the material spectrum are rigid or brittle materials. Those materials that break without yielding, glass for example, those don't work in Simulation Express either. The other limitation of Simulation Express is that the load must be static. In other words, the pressure, the force, the torque, etc. can't change over time. A third limitation for Simulation Express is that the deformation must be small. The rule of thumb here, if you can see your part visually deformed, you've gone too much, and the result probably won't be accurate. Now, if you're comfortable working within these limitations, then Simulation Express is going to be just right for you. Single part, simple constraints, single material, linear material, static load, and a small deformation. I'll be giving an overview of how Simulation Express works in this lesson, and in our next lesson, we'll pick up an exercise using the tool. Let's go to the Evaluate tab, and from here we'll activate Simulation Express. Expand. Simulation Express Analysis Wizard. Let's click Next at the bottom of the wizard page. In my graphic area, I've got a steel plate. The left side will be bolted down with this cut extrude over here. On the right side, I've applied a split line tool. This is the face where I'm going to be applying some load. Notice in the Simulation Express study tree, we've got 3 items: Part 3, Fixtures, and External Loads. The first thing we're prompted to do in the wizard is to add a fixture. Let's click Add a Fixture. Or we can right-click on Fixture in the tree and select Fix Geometry. I'm going to select this face, and this restricts the face in space from any movement. We can select more than one face if needed. For now, I'm going to click OK. And Fixed One is now a fixture in our study tree. To edit this fixture, simply right-click on it and select Edit Definition. Adding another fixture is easy. We can simply return to the wizard and click on the green arrow, Add a Fixture. The Fixture Property Manager opens. Let's cancel out of it for now. Now I'm going to click Next in the wizard. On this page of the wizard, we choose whether to add a force or a pressure. We can do the same thing from the study tree. Right-click, select Force or Pressure. I'm going to add a force. Now I'll select this face. Next, we have the option to apply the force normal to the face or from a selected direction. Let's apply it from normal to the face. Let's change the unit of measurement to the English system, inches, pounds, and seconds. Force value, I'm going to apply 100 pounds. I can check this box to reverse the direction if needed. If we selected more than one face, we can specify whether the load will apply per face or in total. I'm going to click OK now. And Force 1 has been added to our tree. Let's click Next in the wizard. Once again, we can click here, choose Material, or we can right-click on the part in the study tree, Apply Edit Material. I'm going to use AISI 1020 steel. Apply and close. The study tree displays our material applied to Part 3. Notice that the part doesn't display this material selection in the Feature Manager tree above. Basically, the material we use in a study is distinct from the material we select for the actual part in SOLIDWORKS. Let's click Next in the wizard. Now we're going to click Run Simulation. And we see how the part deforms under a 100-pound load. Up in the top left corner of the graphic area, we see that the deformation scale is about 26. In other words, the part deforms 26 times greater here than in reality. Let's stop the animation by clicking on the Stop button in the wizard. Does the part deform as you expected? If so, we'd click Yes and then Continue. If no, we could return to the Loads and Fixtures wizard pages. Let's click Yes. On this page of the wizard, we can review a variety of results: von Mises stress, show displacement. The same items are available here as well on the study tree. Let's double-click on the von Mises stress distribution item in the study tree. A colored stress distribution displays in our graphic area. Down below, we see the yield strength noted at about 50,000 psi, pounds per square inch. Our maximum stress is represented in red here at about 18,550. The minimum stress is 2.6 psi. By the way, the colors don't necessarily mean that red is bad or some kind of warning and blue is good or okay. As I mentioned before, the yield strength is 50,000 psi and the maximum on my model is about 18,550. In other words, the part can hold about 2.5 times more load before it starts yielding. Okay, let's check the deformation. Once again, we've got a deformation scale about 26 times bigger than the actual deformation. The color scale here shows us the minimum and maximum actual deformation. The next criteria we have here is the factor of safety, FOS. In our case, the factor of safety is 2.7. In other words, the part can hold 2.7 times more load before it starts yielding. Let's say we want the factor of safety to be 4, or that we want the part to hold 4 times more load before it yields. Let's enter 4 here, and then click Show. Here in red is the area where the factor of safety is below 4, and that's the area I want to strengthen if I need my part to be able to hold 4 times or more load before it yields. Let's check 6 now, and then click Show where factor of safety is below. As you can see, it's a significantly larger area. The area in blue is where the factor of safety is greater than 6. Okay, we're ready to move along now. Let's click Done Viewing Results. And here we can view our results in an HTML format or generate an eDrawings file. We'll be looking at how to generate an eDrawings file in this course. For now, I'm going to opt to generate an HTML report. And here we've got an HTML report containing file information, material, load, study property, and so on. Let's close the report and click Next in the wizard. The last option is to optimize. Let's say we want the factor of safety to be 4 for our part, but currently it's set at 2.7. SOLIDWORKS will let us adjust a single dimension to meet this criteria. Would we like to optimize our model? Yes, we do want to optimize the model. So let's click on Next. The first thing to do is select a model dimension to use in the optimization. We'll select it right from the graphic area. I'm going to use the thickness dimension of 10 millimeters and click OK. Next, we need to specify the minimum and maximum range. Let's say 10 will be our minimum, and for our maximum, 20. Under Constraints, we can select the parameters by which we'll be optimizing: factor of safety, maximum displacement, maximum stress. Let's use factor of safety. And the factor of safety I'd like to be greater than 4. Click Next. Next again, since we did edit the constraint already. And we're ready to run the optimization. We can simply click this link in the wizard, or we can click on the Run button over here. Let's click Run Optimization. The study is in progress, processing scenarios 2 of 5, 3 of 5, 4 of 5. We can stop any time if we need to with the Stop button, and processing 5 of 5. The optimization process is now complete. Now we've got a factor of safety of 4.9 with an optimal dimension of 15 millimeters. The mass of our model is 1.16 kilograms. The factor of safety is actually a little bit higher than we need, so let's edit that dimension. Edit Dimension. Let's cancel out of the Add Parameters window since I'll be using the same dimension. For the minimum, let's make it 12 instead. The maximum, let's say 15. And let's run the optimization again. Processing the scenarios. Four of 5. And 5 of 5. Okay, the optimization is complete. Now we've got a more desirable result with the factor of safety at 4.009. The thickness of our part, 12.85 millimeters, and the mass just slightly below 1 kilogram. Let's stick with 12.8566 millimeters and click Next. And we have our results. They are out of date. We do have to update them, so let's go back to Run. Run Simulation. And we can generate a new report now. And this concludes our overview of Simulation Express. In our next lesson, we're going to be picking up with an exercise where we put Simulation Express to work.